All right, continuing on with the transformations unit. Now we talked about the different transformations that exist, and now we're going to answer the question that's come up a couple times. Does the order in which you do the transformations matter? Okay, so we're going to go through a couple problems and see if it does matter or if it doesn't. Okay, so this first one, start with the function x squared, and then shift it up 7 units and right 2 units. So up 7 units, we know the vertical translation is what happens at the end. Okay. So up 7 units is going to be x squared plus 7 at the end. Okay. And then from there we go right 2 units. Okay. So going from there right 2 units, the right and left happens inside the function. Okay. Inside the function here means with the x squared. So before you do x squared, you got to do x squared minus 2 to go right 2 units. Square it, and then plus 7 at the end. So that's a transformed function of x squared going up 7, then right 2. This next one's flipped the order. Okay, this one we're going right 2 units and then up 7 to see if that affects our final answer. So right 2 units first, we're going to have to do the minus 2 inside the function. And then up 7 units will be the plus 7 outside of the function. Okay. And we're going to compare, see if we get the same thing. And, it's pretty clear that, yeah, nothing changed. It didn't matter that if we went up and then right, or if we went right and then up. So parts A and B gave us the same equation. So far, order doesn't matter. The second one, now we're starting with the square root of x, so just a different parent function. This one we're going to stretch vertically by a factor of 2, and then shift upwards 5 units. So the vertical factor of 2, remember for a stretch or a compress that goes out front, so you'd multiply by 2 out front, and then to shift it down 5 units, you'd do minus 5 at the end. Again, the vertical translations up and down are always at the end. The dilations, the stretchings, and compressions are multiplied in front, and then left and rights are inside the function. Alright, so now we'll flip the order on this one. Shift down 5 units and then stretch vertically. Okay, so again, the first problem, part A, we stretched first and then shifted down. This time we're going to shift down and then stretch. So again, start with the parent function, which is the square root of x, and go down 5 units. So at the end, outside of the function, you're going to have to do minus 5. And then to stretch this vertically by a factor of 2, we have a new function here. We've got square root of x minus 5. So to stretch that by a factor of 2, we're going to have to multiply that entire thing by 2. So it's 2 parentheses square root of x minus 5. And that stretches the entire function that we have. Alright, so now if we compare those two, well, first we'll distribute the 2 and make it in the same form. And now we compare the two, we have 2 square root of x minus 5 and 2 square root of x minus 10. Those are not the same, even though we did the same operations. Okay. So why didn't it give us the same thing? It's the same down 5 vertical stretch versus vertical stretch and then down 5. Okay. So just like doing order of operations, order does matter in these. When does order matter? And it matters when you have multiple vertical translations or transformations. Okay. So we need to have an order just like with order of operations. We need to have some process to give us the same answer each time. So anytime there's multiple vertical transformations, the order is going to matter. Okay. And vertical transformations can come in 2 forms. You could have a translation, a shift up or shift down, or you could have dilations, vertical stretch or vertical compression. All right, so what order do we use? Okay. There's no acronym like PEMDAS or GEMDAS or please excuse my dear Aunt Sally, but there's only 4 movements that we have. So the order that we're going to use is kind of an inside and outside. You start on the inside and you work your way out. First thing you want to do is you want to deal with any horizontal translations. So a shift to the left or a shift to the right. We're going to deal with that first. The second step would be vertical stretches or compression, so a vertical dilation. Okay, so that multiplies out front. The third step would be any reflections. Okay, remember we're only reflecting over the x-axis. And then the last step is vertical translations. Okay. Now again, in function form, it's starting on the inside and working your way out. Okay. So we just write a general function, f of x, and we perform the, if we put in every type of transformation that we have, we do f of x minus h, that's the horizontal translation, plus k at the end is a vertical translation, and then the a out front. The a out front deals with two things. Okay. So the order here is we do the inside first, inside the parentheses. The a value deals with the stretch and the compress as well as the reflection, and then plus k at the end is the fourth and final step. So start inside and work your way out. Alright, so let's look at some example problems. I crossed out the domain and range part, we're not going to deal with that. So first we're going to start with listing the parent function, then we're going to list the transformations, and we're going to list the new origin. Okay, so what changes about the key part of our graph. So in this one, we know it's an x squared graph because it's something squared. The minus 2 on the inside moves it right 2. The 3 on the outside stretches it by a factor of 3. And then the plus 3 at the end moves it up 3 units. So how do we find the new origin? Well, the original origin for x squared parent function is 0, 0. So if you move right 2, you're now at 2, 0. If you stretch by a factor of 3, the stretches only affects the y value, so you're at 2, 0 still. And then you go up 3, which puts us at 2, 3. So remember, the vertical stretch multiplies the y value. Now again, most of our origins start at 0, so it's not going to affect the y value in this problem. Second one, it's got a radical. It's a square root parent function. The plus 2 moves it left 2. The 4 on the outside stretches it by a factor of 4. The negative on the outside reflects it over the x-axis. And then minus 1 at the end moves it down 1 unit. So where's our new origin? Well, parent function origin starts at 0, 0 again. Okay. Move left 2 units puts you at negative 2, 0. Stretch by a factor of 4, again the y value is 0 so it doesn't change. Reflect over the x-axis, again only the y value would change and it's 0. And then move down 1 unit, moves us down to negative 2, negative 1. Alright, this next one, parent function is absolute value. Okay, so absolute value of x is the starting point. Current origin is at 0, 0. Plus 2 inside the bars, inside the function, moves it left 2. The minus on the outside reflects it over the x-axis, and then minus 5 at the end moves us down 5 units. Where's our new origin? Well, it starts at 0, 0, left 2, down 5, negative 2, negative 5. All right, and this last one, parent function for this is a cubic. It's x to the third power. There's nothing being added or subtracted inside, so our first transformation is going to be the compression by a factor of 1/2. Second is the negative that's out front, which is going to reflect it. And then the last transformation is the plus 1, moves it up 1. Okay. Where's the new origin? Starts